For this one, the suggested means is to use the quadratic formula. So let's recall that and have this at the ready in your notes. Those of you in my section and Mr. Durda's, you can have a page of notes. So I would recommend that you have this negative b plus or minus b squared minus 4ac over 2a. Our a here is 1, the number understood to be before the x squared. Our b is 2, and c is 5. We're going to go right into our quadratic formula and find our solution for x, negative b plus or minus square root of b squared is 4. 2 times 2 minus 4 times 1 for A and 5 for C, then over 2 times 1 for A, 2. So that leaves us with negative 2 plus or minus square root of 4 minus 4 times 1 and 5 for 20 over 2, negative 2 plus or minus square root of 4 minus 20, negative 16, all over 2. Then let's come up and simplify what we have. We have x equals negative 2 plus or minus square root of 16 is 4. The square root of a negative under that square root is 5, right? All over 2. And lastly, we want to say, okay, we have negative 2 over 2 plus or minus 4i over 2. So the first part can reduce to negative 1 by dividing 2, and the second part can reduce to 2i by dividing 4 by 2. And that leaves us with our two solutions, negative 1 plus 2i, comma, negative 1 minus 2i. There needs to be a negative in front of that one. Go ahead, Keith. What was your question? Looking back here, we have 4 times a times b. The 4 is in the equation, the formula. A is 1 and b is 5. For 4 times 5 is 20. And then we got a minus. And one of those things were negative. The minus stays. So to recap, we applied the quadratic formula there. Why was that the suggested method? Notice the solutions are complex. Negative 1 plus 2i, negative 1 minus 2i. If we had tried to use factoring or square root method or anything else, then we probably would have gotten stuck or had to work it in a really long way. That's what quadratic formula was suggested there. So try to have at least some comfort with all the different methods for solving quadratic equations. This one is also suggested that you use the quadratic formula. To set that up, you would want to add 10x to both sides so that it is on the left with all of your other terms. Add 10x to both sides to get here. Then you have A13, B10, and C1 to then plug into your quadratic formula and solve it from there. Since we just did one like that, I'm not going to go further with that. I just wanted you to see sometimes it might be necessary to move the term. That way you get the sign right on the B part. Notice if we just took it as is and said B is -10, we're going to get the wrong answer. We're using that as given. But think about what it looks like after you move that term, so that they're all together on one side with 0 on the other side. Then you can use the ABC from that view, like on the second line there. You may have items like this that suggest you factor to solve the equation. Notice there's an x in every single term given here. We have x in x to the third, and it could take one out, leaving us with x squared. Take one out of the middle term, we're left with one of those x's, and the last term leaves us with just 6 after taking an x from it. Then we're in a situation where we can further factor the x squared expression by reverse FOIL strategy. We know we need x in those first two places. And then what will add up to +5, you might have to do a couple of tries there and then find that it would be +6 minus 1 as our factors do. Check as you go. If you chose 2 and 3 first and check that, you would see we don't get +5 in the middle. So check as you go to ensure that you've got the right factors. And from here, we would set each of these equal to 0. By subtracting 6 on both sides here, that's going to leave us with x equals -6. And by adding 1 to both sides here, that would leave us with x equals 1. So all of our solutions together, 0, -6, and 1 in this case. You'll also see equations with square roots, like square root of a -2 minus 3 equals 0. Find the real solutions of this equation. So remember, the strategy here is to get the square root pieces by themselves. We can do that by adding 3 to both sides to start. That leaves us with square root of a -2 effectively on the left by itself, 3 on the right. How do we go from there? We square both sides. So we've set ourselves up well on the left to cancel that square root of a -2, to leave us with just a -2. 3 times 3 on the right for 9. We can then add 2 to both sides. And we've got a equals 11. we would want to sub that back into the original equation just to make sure we don't get a negative sign up under that square root. We can eyeball that and say 11 minus 2 is 9. No problem, positive 9. You could check further in your, by writing or in your head if you wanted. If you're pressed for time, I would just do that spot check to make sure that there's no negative happening under the square root sign. So some other variations on that might look like this. Square root of x plus 6 equals 2 times square root of x. Since nothing is added or subtracted like the last one where we had a plus 3 next to the square root. Here, while it looks like we have something in that 2 that's not like a square root, because it's multiplied by that square root of x, we're already ready to square both sides. So let's set that up, squaring the left, squaring the right. What do we have on the left-hand side? Canceling that square root, just leaving us with x plus 6. On the right-hand side, we have to think about that differently for those two pieces. There's a 2 times 2 there, 4. 2 squared is 4. And then there's a square root of x, which, when squared, is just a cancel that. Okay. Now, where would we go from here? Minus x on both sides to get all of our x terms together. 6 is left on the left, 3x is left over here on the right. And then let's divide 3 on both sides. 4x equals 2 is our solution there. So we just did with the square root solving the equation. Now notice we're looking at inequalities. We solve these very much like we do those in section 1.1. We're solving simple linear equation strategy. So if it's 4 is like this 13 over here, I might subtract 4 on both sides to get started. That would leave me with negative 3x is less than 9. And next step would be divide negative 3, divide negative 3. Remember when you're working with inequalities to flip the direction of that sign whenever you divide a negative quantity. So we've got x is greater than negative 3. In interval notation, since we're greater than negative 3 would be our leftmost point, and then we would go up to infinity. Parens on both, because we always use paren on the infinity, and since it's not allowed to be equal to negative 3, we use a paren on that side as well. On the number line, find your negative 3. Open dot, since we're not allowed to equal 3, and then pointing to the left. I'm sorry. My bad there, right? Pointing to the right. You want to use the marker over here. There was some reason I made so much room over there. It's getting ahead of my thought. X greater than negative 3. Similar problem in number 20, 4x minus 4 less than or equal to -5. That is, now we have the equal sign with our inequality, but the solving strategy works very similarly. We can add 4 to both sides to start simplifying this. 4x left on the left, -5 plus 4 for -1. Then divide 4 on both sides. We're not dividing a negative quantity here, even though we have a negative already on the right. We're not dividing a negative there, so keep the sign in the direction as given. We've got -1 over 4. We're less than or equal to that value. So since we can be equal, we would use a square bracket on the right-hand side, since that's our rightmost point, -1/4. And then anywhere less than that, so we're going down to negative infinity, always use paren on your infinity. And then a number line, that's going to be pick up from somewhere between 0 and 1, right? It's going to be 0 and -1. It's going to be -4. So we'll come in there as precisely as possible, where 1/4 might be a quarter of the way from 0 to -1. And then we want to be less than that point. So coming this way. Notice I use solid dot on that one, since we are allowed to be equal to -4 in this with the less than or equal to sign. You're also going to see variations on that same type of problem, like this. So notice there's a lot of distribution involved there. Once you've got that distribution taken care of, then you're ready to solve the inequality, just like the last couple that we looked at. One thing that we have not yet looked at is absolute value equations, like this. Absolute value of 2x plus 7 equal 9. How would we solve that? Remember, for absolute value, we have to consider that this group could equal 9, or this group could equal -9, and that would be true in both cases if we're looking at absolute value. Absolute value of 9 would be 9, absolute value of -9 would also be 9. So we have to consider solving for both cases. Let's solve for this left one here by subtracting 7 on both sides. That gives us 2x equal 2. Divide 2 on both sides, leaving us with x equals 1. Now, moving on to the other one. It'll look similar, but you're going to end up with some different results because of that negative. -9 minus 7, that's -16. Divide 2 on both sides. That'll leave us with x equal -8. So our solutions there are 1 and -8. You'll see variations like this, combining that strategy we just looked at with inequality. So we have to be careful when we set these up. The first one will be as given, so greater than or equal to +2. The second one, when we introduce the negative sign, will be like dividing a -1 on both sides. So we need to flip the direction of that sign when we make the negative equation, that second one. So we introduce the negative, flip the sign. Now we're ready to solve each of these, +6 on both sides. X is greater than or equal to 8 on that one, +6 on both sides here. X is less than or equal to 4 on this side. Let's look at the number line to see how those match up. Greater than 8 and equal to, so we could use solid dot and come over here, greater than or equal to 8. Then 4 is going to be somewhere over here, right? 4 is going to be somewhere over there. Then we're less than or equal to 4. We were greater than or equal to 8, but less than or equal to 4. So that's going to be solid dot on our 4 and going left. That's a solid dot, by the way. On both of those going left, so that's to the left. So we've got one that split. Sometimes you might have the meat in the middle. That one splits in either direction. And how would we write that in interval notation? So we've started at -infinity, gone all the way up to 4. Start at -infinity, go all the way up to 4. Then we stop for a little while. That's U. And then pick back up at 8 and stop at infinity. Now, what do I have wrong about what I just wrote down? Good. He picked up that we are allowed to be equal to 4 and 8. So don't use those parentheses, use those square brackets. Good. (3x minus 2), absolute value is less than 5. I'm just going to set this one up for you all. We would use as is for our first equation. And then we would introduce a negative on the number 5 for our second equation, while also changing the direction of the sign. That is, it's a greater than there and a -5 over here. Solve both of those inequalities just like we did, and write down your interval notation as well as map out your number line. We're running a little short on time, but I think we have enough to go ahead and look at this. Let's add 2 to both sides. That gives us 3x is less than 7. Divide 3 on both sides. That will leave us with x less than 7/3. Over here on the right, as we add 2 to both sides, looks similar, but we're going to come up with a -3 here. Divide 3 on both sides. We're dividing a positive, so we don't flip the sign. Even though it looks like there's some negatives involved there, we divided a +3. It's divided from a -3, giving us -1. Less than 7/3, greater than 1, both not allowing equality, so we use open dot, parentheses in our interval notation. X greater than 1, -1, and X less than 7/3, right? Isn't that what we had? Less than 7/3, greater than -1. So greater than -1, let's start there. -1 is going to be our leftmost point if we're greater than it. And then less than 7/3, that's positive. So we're going to run into that as we go up from -1. If you don't see that immediately for your interval notation, look to your number line for clues or some insight. 7/3, that's higher than 1. Is it higher than 2? Yes, 7 divided by 3 is 2 point something. So check your calculator if needed to figure out what's going on there. We've got open dot on -1, open dot somewhere slightly to the right of 2. That 7 divided by 3 would give us 2.33. If we check that in our calculator. So a little bit past 2. And then notice these are joining in the middle because greater than -1 is going to go this way. Less than 7/3 right here is going to come to the left this way. So those are meeting in the middle on that particular example. And that is a full look at the breadth of problems you're going to see on your test for college algebra. Be ready to run with these types of problems once your test starts, whether it's Tuesday or Wednesday with me or whatever. I've gone over the full breadth of problems that you're going to see on the exam. So you need to master these. I'm going to send out the videos. There'll be 2 videos since I had to split it on my Zoom account. If you're not in either of my sections, if you're not in my 1298 Tuesday, Thursday, or my Monday, Wednesday, 1300 class, write your email on this sheet before you leave so that I can email you those videos from today's review session. I wish you all the best of luck. If you have additional questions, I know some of you have additional questions. I will be moving next door for 15 to 30 minutes or so to address those individual questions. Also, if you're hungry still, help yourself. Got plenty of food over there. Best wishes on your test.
Thank you, Fred.
You're welcome.